Hello, students. Welcome to whatever theorems. We're gonna go over what theorems we should use during the test. I mean, yeah, if you want to, not forcing anyone. So, in red is going to be important for you to know, and then in the blue is not coverage or not important. Alright, and now let's dive into the things. So any 2 points, there is exactly one line. You're probably not going to know this, so this would be blue. If two distinct lines intersect, they intersect in exactly 1 point. Two distinct lines intersect in this. These are just basic knowledge, not really like you have to use them in a proof. Same with this, same with this. Ruler postulate, every line is same with this. This is just basic knowledge. Okay, now to the real stuff. Segment addition postulate. With 3 points, then AB plus BC equals AC. Now, I think we used this before and we were taught this, so we probably should know about this. I mean, not really study it that hard, but just know about it. It will be everywhere, it can be used. You don't need to know this. If addition, point B is in the interior of angle AOC, angle addition, yes, this would be pretty good to know as well, and so is this. So perpendicular is right angles, so that would be like, this would be definition of perpendicular, and that would be important for you to know to create right angles. Let's see, linear pair postulate. If two angles form a linear pair, then they are supplementary. This is pretty important as well. So if you know that 2 points, 2 angles are close to each other, linear pair, and you can say that they're supplementary or like a linear pair. So these are all good. Okay, let's see. Law of detachment. Is pretty obvious. Hell no. P, Q. This is just pretty much transitive property. You don't need to know this. I'll just like underline it if you want to see. This is blue. Q is true. Symmetric property. If AB is CD, if A... I mean, I don't think you do, but I mean, this is just like, I don't know, strange. This is, if you want to do like symmetry, no, it's probably not gonna be symmetry on the test. Transitive property, definitely, almost all of them have transitive if we're trying to prove congruence in a triangle. Reflexive, definitely. Vertical angles, definitely. Congruence supplements, if two supplements at the same angle. So this is just supplements. This is just transitive, so congruent complements, supplements. These are transitive. All right angles are congruents, and this would be you don't. This is not like a theorem. It's rather like you have to prove that all right angles are 90 degrees, and therefore you can say whatever is 90 degrees is equal to that. If two angles are congruent and supplementary, then each is a right angle. Two angles are congruent. Well, this is pretty useful to know, but it's not going to be very important. You're not going to use this necessarily. Let's see, same side interior angles. Yes, this is great. Corresponding angles, yep. Converse, yep. Any converse and same side. These all you have to know. If you ever have parallel, you have to know all of these. Next set of rules. take a screenshot or whatever so we can study these. Hey guys, so if two lines are parallel to the same line, then they're parallel to each other. This is transitive, I think. Few lines. Yeah, I don't think you need to know this. This is what parallel postulate. Though a point not a line, there is only one and only one line parallel to the two point not a line. You don't need to know this, but it's like pretty it's, like, rules, whatever. Triangle angle sum theorem, definitely you need to know this one. If they ever ask about like sum angles, well, whatever, fuck, yeah. Oh wait, it's not 1 minute. Okay, I can say any curse words I want. Sir, if the line is perpendicular to one of the two parallel, you don't need to know this. Probably not. Probably, yeah. What? Triangle exterior angles. I mean, you can use this, but this is just, you can solve this on your own, like, using whatever else theorems. Don't need to know this. It's just rules. Slopes are parallel. These are just I don't know. So you probably have to know them, but they're not gonna be used. These are not going to be used as a theorems. So no, not used. Even if I'm highlighting as red, so whatever. Spherical to a point. What the hell? This is bad. Spherical geometry. We're not doing spherical geometry. Okay, definition of midpoint, definitely. Definition of right angle, definitely. Congruent angles, definitely. Isosceles, definitely. Supplementary, definitely. All of these, segment bisector, yes. Angle bisector, yes. Okay, overlapping segment theorem. Overlapping segment theorem. If two adjacent overlapping, yeah, you don't need to know these. What the hell? Okay. If two of the angles are congruent to two angles of another, then the third angles are congruent. This is just like we prove side, whatever, prove a triangle. So you don't need to know this. Side, definitely. Angle, side, angle, definitely. Side, angle, side. These are postulates. Isosceles triangle with two sides and opposite. Opposite, those sides are congruent. We don't need to know corollary. If two sides of a triangle are congruent, and angles opposite those sides are congruent. This is me. You probably don't need to know this. Angle side, yep, you do need to know this. There's just like whatever. Hypotenuse leg, this is great. If the hypotenuse and the leg of one right triangle are congruent to the hypotenuse and leg of another triangle, then the triangles are congruent. So let's say like this, right? So hypotenuse congruent, and then in the leg, these are congruent of right triangles. You can say these are right triangles, so side, angle, side. Yeah, that was good. If a line bisects the, yeah, no, probably not. Triangle sum. Yes, you should know this. You should definitely know this. Not this, I think. But yes, you should know this. Know this as well. Just know this formula, anyways, too. Sum of the exterior, yep, it's great. Okay, all of these, parallelogram, opposite sides, consecutive angles, supplementary, opposite angles, congruent, bisect, what? So you should check out Caden's video on quadrilaterals, and he explains all of these. But however, I'm just telling you if you should use these, which you definitely should. So all of these are great. So if opposite sides are congruent, then it's a parallelogram. These are just like converses, I think. So when it's two parallelogram, it's converse. The right side is converses, the left side is just normal. This one is the converse. Angle supplementary to both sides. Okay, whatever. Okay, once again, you should check out Caden's channel. I mean, not channel, I have the channel. About video about these. So trapezoid mixed segments, yep. And these are all good, all good. Study each and every one of these. Now, I don't know if you have to get every single word of the theorem or postulate correct, and if you want to have the postulate, the word postulate or theorem. I don't know if they're gonna take off points for that. So that's like kind of scary. Oh no! Bisected theorem is equidistant. You need to know this. This is just converse bisected. These are just like medians. You don't need to know this, but actually concurrent means they meet up at one point. These are called the in-center, centroid, orthocenter, and the circumcenter. So it's perpendicular bisectors. These are just whatever. They just state the centroids. This is just basic triangle knowledge, and don't know about this. Hinge, probably not this one, and this one probably not. Triangle inequality theorem, oh wait, yeah, this one you have to know, not these. Okay, students, once again, my mic did not work, and so I was basically saying that you should only know that the triangle, whatever, two smaller sides have to add up to over the longer side, and whatever this, Now I'm going to be talking about the side splitter theorem. So here we go. Okay, so the side splitter theorem basically states that whenever a line that is parallel cuts the triangle into two to the base, parallel to the base, cuts the triangle into two segments, then this over this, so AD, let me draw this, AD over DC, not the entire thing where I got messed up, it's AD over DC. So AD over DC is congruent, I mean the proportionality is over AE over EB. So just these things. So AD over DC, same line, and AE over EB, same line. These two segments, no holes, okay? No hole segments. So let's say AD is 7 and AE is 9 and EI is 18. So AE over EB or EB over AE doesn't matter as long as they are on the same side, or like the same side of the proportion. So either 18 over 9 or 9 over 18 is equal to 9 over 18. So DC over 7 or 7 over DC. What you would get is 18, 7 DC. So you would get this is 14. I did not do that mentally, so I just looked at something. DC would be 14. Look, 7 over 14, 1/2. 9 over 18, it's also 1/2. So these proportions are congruent. But then let's talk about the geometric mean. That one is a confusing one as well. Also from the similarities units. Okay, hold on. This is crazy. Whatever. Okay, let's see geometric mean. What does geometric mean? So basically, when you have a right triangle, let's draw this. When you have a right triangle, you go from the right triangle vertex down, straight down. This is the altitude. Draw the altitude. You make this congruence and this congruence. These are right angles. So you make right angle, right angle. Remember, this is the altitude. And so the basically geometric mean basically means this part, this segment times this segment times each other is equal to the square root of the geometric mean. For example, let's say this is 3. And so you would have to get 9. Let's see. What gets 9? 3 and 3. So 3 times 3 is 9. And the square root is equal to 3. Wow, how nice. So basically, remember, for these two whatever theorems, you use the not the whole segments, just the parts of the segments. So this is a part, this is a part, and do this, and voila. Alright, remember to square root this, or else it's gonna be wrong. Anyway, students, I hope you enjoyed that video, and I would like to give you a good luck reminder. Good luck. Bonam Fortuna on your test tomorrow. I'm gonna be making another video about directed line segments and like altitudes, whatever, directed by whatever. Bye bye, good luck students. I hope you luck. Woo.